All right, let's dive right in. Every single time you shoot off an email or binge watch a show, what feels like magic is actually a tiny miracle of logistics happening behind the scenes. So in this explainer, we're going to pull back the curtain on the invisible, split-second decisions that literally make our digital world go round.
I mean, seriously, have you ever stopped to really think about that? You hit send on an email, and that message just zips across the entire globe through this insane, tangled web of networks to land in the right inbox pretty much instantly. How on earth does that happen? Well, the short answer is thanks to a little unsung hero we call a router.
Okay, so to really get our heads around this, let's use an analogy. I want you to think of every single router out there on the internet as a super fast, super intelligent post office. Its entire job, its whole purpose in life, is to get a piece of mail and, in a flash, figure out the very next post office it needs to go to, just getting it one step closer to where it's supposed to end up.
And sticking with this analogy, your email, or that photo you just double-tapped, or even this very stream you're watching right now, it all gets broken down into these tiny digital letters. We call them packets. And just like a real letter, each one has a very specific destination address written on it. The router's job? Read that address and sort it. Fast. But here's the dilemma. You see, unlike your local post office, a router might have dozens, maybe hundreds, sometimes even thousands of different paths it could send a packet down, and it has to make the absolute best choice in a tiny fraction of a second. So how does it pull that off? How does it choose?
Well, the secret is something called a routing table. You can think of this as the router's brain, or its digital map of the entire network. It's basically a big list of all the places it knows about and the best ways to get to them. So, to figure out how it makes these crazy fast decisions, we need to learn how to read its map.
First thing on the map is the prefix. This is pretty simple. It's just the zip code for our digital letter. It's the general neighborhood the packet is trying to get to. Now, see that number after the slash 28? That's super important. It tells the router how big that neighborhood is. And here's the key. A bigger number actually means a smaller, more specific area. Kind of counterintuitive, but stick with me.
All right, next up we have the next hop. And this is absolutely crucial. The router's map doesn't show the entire trip from your house to Australia. No way. It only knows one thing, the address of the very next post office in the chain. The journey is made up of a whole series of these little hops from one router to the next.
Okay, now this is where things get really cool. It's a concept called administrative distance, or AD for short. See, a router might hear about the same destination from a bunch of different sources, so how does it know who to believe? AD is just a trust score. Simple as that. The router will always trust the info it got from a source with a lower score. Lower is better, more trustworthy.
And finally, we have the metric. So if administrative distance is all about who to trust, the metric is about which path is actually the best. It's a cost value. You can think of it like, well, travel time or efficiency. Just like you'd probably pick a direct flight over a 3-day road trip, the router always picks the path with the lowest cost, the lowest metric.
Okay, so we've got the terms down. We know what's on the map. Now let's walk through the router's actual decision-making process, step by step. And the very first rule, the most important one that trumps everything else, is called the longest match rule.
You know, this one is actually super intuitive when you think about it. If you're mailing a letter, which is more helpful? An envelope that just says Springfield, or one that says 123 Main Street, Springfield? Obviously the full address, right? It's more specific. Well, the router thinks the exact same way. It will always, and I mean always, choose the most specific, the longest matching address in its map.
And this is a perfect example of that rule in action. So a packet comes in and its destination is 172.16.0.10. The router checks its map and hey, it finds 3 different routes that could technically get it there, a /12, a /18, and a /26. But remember what we said? Bigger number, smaller neighborhood. So because that /26 is the most specific address, the router picks that one. No questions asked, end of story. The other rules we talked about, they don't even get a look in yet.
Here's another great way to look at it. Let's say a packet wants to go to 8.8.8.8. The router is going to look for a match in this exact order. First, it looks for a /32. That's a perfect match, a single house on the street. If it finds that, it's done. If not, it looks for a /24, then a /16, and so on, all the way down to the most generic route possible. The most specific match always wins. So we've established that the longest match is king, period. But what if there's a tie? What happens if the router finds two different paths that are equally specific? How does it choose then?
Aha! This is where our trust score, that administrative distance, finally gets its moment to shine. If you've got two paths with the exact same prefix length, the router's very next move is to check the AD for each of them. And it's simple. It just picks the path that came from the more trustworthy source, the one with the lowest AD score.
And here you can see the default rankings for that trust score. A route to a network that's physically plugged right into the router, that gets a 0. Can't get more trustworthy than that. A route that a human manually typed in, that gets a 1. Pretty reliable. And then you have all these different automated protocols, each with its own built-in trust level. The router just goes down the list and picks the lowest number it finds for that route. Okay, you're probably thinking, what are the odds? And yeah, it's not super common, but it can definitely happen. What if a router learns about two equally specific routes and they both come from the same protocol? That means they have the exact same trust score, the same AD. Now what? There's got to be one last tiebreaker, right? You bet there is, and that final, ultimate tiebreaker is the metric. When absolutely everything else is equal, same specificity, same trust score, the router looks at the calculated cost for each path. This cost could be based on connection speed, how many hops it takes, all sorts of things. The router just looks at the numbers and picks the one with the lowest cost. The most efficient trip wins. So, there you have it. That's the core decision process. But there is one last scenario we need to cover. What happens if a packet shows up for a destination that the router has never even heard of? It's not on the map at all. Does the router just give up and throw it in the trash? Well, not necessarily. A lot of routers have what's called a gateway of last resort. Think of it as a pre-programmed default path. It's the router's instruction for what to do when it's totally clueless. It basically says, look, if you have no idea where this goes, don't panic. Just send it over to this specific router and let them deal with it. It's the ultimate when in doubt, send it out option. So let's boil all that down into the router's simple 3-step decision. Rule number 1, always find the most specific path. The longest match is king. If there's a tie, move to rule 2. Check the trust score and pick the one with the lowest administrative distance. And if by some chance that's still a tie, rule 3 kicks in. Just pick the path with the best cost, the lowest metric. That's it. Simple, elegant, and ridiculously effective. And here's the part that just blows my mind. This simple 3-step decision, this little logical dance we just walked through, it happens billions of times, every single second, on millions of routers all across the planet that weave our world together. So really, it is no exaggeration at all to say that this invisible, lightning-fast logic is the true backbone of our digital lives. It's this hidden, silent, instantaneous sorting system that makes everything you do online, from sending a quick message to streaming a movie, even possible. Think about it. We've just followed the journey for a single packet. Now, what does it take to manage the trillions of them that are zipping around the globe every single day? It really makes you appreciate the incredible, elegant logic that our entire connected world is built on.